So what do we mean by noisy target? Here we mean that the target function isn't always a simple mapping from X space to Y space. For example, we could consider the case where we have two identical customers for a loan approval, have the same type of standard criteria. They might be 32 years of age, male, and have the same salary. However, because two different loan officers looked at these different applications at different points in time, one could have been approved and another one might have been rejected. So we could try to characterize these sources of noise as part of the outcomes in the target function. So these are noisy targets in the sense that the outcomes are different. So let me ask you, do you think that misreporting the salary data as part of the input would consider a case of a noisy target? To make sense of noisy targets, it helps to think of it as a target distribution instead of a specific function. So instead of thinking that there's a specific outcome y, we're going to think of it as a probability distribution, just like in naive Bayes, where we think that there's a probability of a certain outcome given the data. So our data xy, the tuple of all of the examples and their labels, are now going to be jointly generated from a distribution where you have a prior probability of the data itself. In naive Bayes, we call this the marginal, as well as the data likelihoods, right? The probability of the target having a certain value given that the data is like so. And for noisy targets, we can think of this as a deterministic target function f of x, which gets the expected value of a label given the data, but we've added in some noise factor, which is affecting the actual value of the y that we actually observe. We can think of the easy case of the deterministic target function as a special case, where pointwise it is the case that y equals f of x, and everywhere else besides that point, the probability of the other labels of y are 0. To put this together in summary, it helps to go back to the learning diagram with the noisy targets in mind. Here, we're just going to permute the first box and say that the target function is going to not be a simple linear mapping, but subject to some noise that we might not be able to control, but we observe anyways. So it's going to turn this into a probability distribution where we have a P of a label given the data. So this would constitute a noisy credit approval process. To summarize, we can think of having not just a simple linear mapping of y equals f of x, but that it's generated, the labels are generated by a probability distribution. Given a particular x, we are going to find the probability of a particular label given that.